Hello. In this video, we want to set up the integrals that would find the area of the finite region bounded by x plus y squared equals 2 and y equals negative x. We want to do this first with respect to x and then again with respect to y. So, in general, for any of these problems, the first things we want to do is know what does this graph look like. So taking a look at these functions, we have the function y equals negative x, which we know is just the line with that -1 slope. And then we also have x plus y squared equals 2. With a little bit of rearrangement, this is also x equals 2 minus y squared. This is another parabola that opens up to the left. So we have 2 minus y squared here in blue. So it intersects twice here and here. We want to find those points. So we're going to set these equal. To make our variable the same, y equals negative x is the same as x equals negative y. It's by dividing both sides by a -1. So finding our intersection points, means we want to set those two equal to each other. So 2 minus y squared is equal to negative y, or 2 plus y minus y squared equals 0. This is a factorable quadratic of 2 minus y 1 plus y factors there. And then that tells us that y either equals 2 or y equals -1. Using the equation x equals negative y, that gives us the x coordinates of x equals -2 and x equals 1. So these points are -2, 2, and 1, -1. So here is 1, -1. Here is 2, or -2, 2. Two is to set up our integrals. Which, with respect to x, we need our functions to be in terms of x. So we have y equals negative x is already in terms of x. But this y squared plus x equals 2, to get that in terms of x, we get y squared equals 2 minus x, or y equals plus or minus the square root of 2 minus x. So we actually have two functions there in terms of x defining our blue curve. And we actually need both of those because if we notice, when we're in terms of x, over here, we have the upper function being the positive 2 minus x square root, and the bottom being the negative square root 2 minus x. So when we set up our integral, we're going to need both of those. Remember, upper minus lower. So looking at this, from -2 until x equals 1, we have that upper square root, the square root 2 minus x, being the top function and the negative x being our lower. So that happened from -2 to 1. And then from 1 until the end of this, which is 2, x equals 2, we have that upper square root, the square root 2 minus x, is above minus the negative square root 2 minus x being the lower function. A little bit of a rewrite gives us -2 to 1 square root 2 minus x plus x dx plus the integral from 1 to 2 square root 2 minus x dx. So those two integrals in terms of x would find the area between those two curves. Now, with respect to y, we actually have everything already set up. We have already found the intersection points. I will put that line back in. And we are still finding this area, but when we're in terms of y, we're doing the right function minus the left function. And the parabola is always on the right, and the line is always on the left. So our integral is going to be the integral of the right function, the parabola, 2 minus y squared, in terms of y. So that was our function in terms of y, minus our function in terms of y, which is -y dy. And our bounds are the bounds in terms of y. This is happening between -1 and 2 along the y-axis. So those are our upper and lower bounds, giving us the integral -1 to 2 of 2 minus y squared plus y dy. These two integrals would find the exact same area, but one of them is going to be a little bit of a quicker solve if we needed to work it out. We can find the area between curves both with respect to x and respect to y, and they would give us the same answer.